folks, in this video we're going to be looking at problem number 2, which is the calculation of atomic mass based on isotope masses and the abundance of each isotope mass. And so here we've got iron, and we've got in this little table here we have the various isotopes of iron that appear in nature and the masses in atomic mass units of those isotopes. We'll notice that one of the isotopes, iron 56, is the one that dominates. 91.66% of what appears in nature is iron 56, which actually happens to be the most stable isotope / nucleus of any element in the periodic table. More on that later. And so when we do an atomic mass calculation, it's what's called a weighted average. And that doesn't mean we're going to take we're not going to just simply take our 4 isotope masses and average them together, because that doesn't account for the fact that they're different abundances. The fact is that almost 92% of the iron that's in nature is iron 56. And so the atomic mass should reflect that most of the iron that appears in nature is iron 56. So the way we calculate the weighted average is we will take the mass of each isotope and multiply it by its percentage, not percent, percentage abundance. And what that means is, so for example, iron 54. All right, iron 54 has a mass of 53.940. We're going to multiply it by its abundance, which is 0.0582. In other words, what we've done to figure out the percentage is simply divide each of these by 100 when we are doing the calculation. All right, so we go through this and we're going to do iron 54, 0.0582, iron 56, and so we got 0.9166, that's the 91 multiplied by its mass, 55.935, 0.0219, 2.19% times the mass of iron 57, and then finally 0.03033 multiplied by that. So that's a weighted average. And so we're going to take those values and add them all together, and this gives us our atomic mass of 55.85 AMUs, which is what's in the periodic table. So when you do these calculations, you should actually compare your answer to what's in the periodic table. You should get the same answer depending on the precision of your calculation. You should get the same answer as what's in the periodic table. If you do not, then you have made a mistake. All right? So that's one quick check to make sure you got the right answer. So again, remember this is a weighted average and we have to multiply each isotope mass by the corresponding abundance. Hope this is clear. Let me know if you have any questions.